Hi everyone, this lesson is going to be about how we use GeoGebra to create different exponential functions and the transformations of those functions. So I'll just start up a fresh GeoGebra calculator here in my browser. So nice. To begin with, I will have to have some sort of a number for the base of my function. I'm going to call that k, and now, because it's the base of an exponential function, we don't want this to be negative, so I'll use the slider command. In fact, I don't even want it to be 0, so I'll put the minimum of 0.1, let's go up to 10, and let's go in increments of 0.1. So there's my value of k, and that's nice. So I'll just set that at around about 2. There we are. Now, oops, I don't know why that happened. Now I'll have my function, so f of x equals k to the power of x. Lovely. And immediately we can see a couple of good features about this. The exponential, the simplest exponential function is just a base to a power of x, so it'll always have an intercept here on the y-axis of 1 when x equals 0, 2 to the power of 0 equals 1. In fact, if I change the base, I'm always going to get an intercept of 1 because, you know, say if I had the base of 10, 10 to the power of 0 is 1 as well. Now, another few interesting things to remember about this, let's just set that back to something like 3. If x equals 1, then 3 to the power of 1 equals 3. So we're always going to get a point here. In fact, why don't I just grab hold of a point, and if I click the point tool and then click the function, that point will be locked on. And now don't forget to click that little move icon, and then I can drag the point around. Importantly also, a little right click and do the settings. I can show the name and the value of that point, so that's handy. So why won't that jump accurately? There it is. So that's what I was talking about, when x equals 1, and if I go back to my algebra window, when x equals 1, then 3 to the power of 1 is 3. Another key point would be down here when x equals -1. If I can, why won't that? Usually it jumps nicely to those values. That's slightly annoying. It's close to -1, and of course 3 to the power -1 is 1 over 3. So that's nice. Perhaps if I go to the settings and reduce the decimal points. So let's reduce the decimal points to 1 decimal. That's a bit annoying. Let's go to 2 decimals. That's slightly better. Now hopefully that was it. See how that snapped onto that point there? And there. But it's not doing it on the negative side for some reason. How annoying. Okay, so now that's interesting. And as I change this, then say I put that equal to 4. Come on, 4. Having trouble controlling my mouse today. So as you'd expect, then the key point there is the function has a value 4, and down here the function has a value of 1/4. That's nice. Now let's do some transformations. So if we're going to transform a function, there's 4 parameters, so I'll call them A, B, C, and D, and I've just accepted the default slider values there from -5 to +5. Now I'll need a new function with these parameters, so I'll call this one g of x, and it will equal a multiplied by, now my original base was k, to the power of, and I'll have bx plus c, and then add d at the end. So that's my generic function, a times k to the bx plus c plus d. Now let's just set these to some sensible values for a minute. I'll set c and d equal to 0, so effectively it's a times k to the bx, and you can see it right down here, 1 times, that's really just the same, it's 4 to the power of x, it's the same. Let's see what happens as I start moving around a. A is the vertical dilation, so we can move a across a bit, and what's happening if a equals, say, 5. Let's have a point on my new function, And let's also, oh sorry, I didn't mean to turn off the algebra then. Let's also display the coordinates, the name and the value of that point. So, oh, that was nice the way that did there. So my value of A is 5. It's a vertical scaling factor. So the Y value is multiplied by 5. If I put that one there, and if I put that one off the top of the screen, up to there, the vertical scale factor multiplies the Y value. The Y value is multiplied by 5. That's how that works. If the vertical scale factor is 2, then you can see it's multiplied by 2. If I was to put that point there, almost, and I'll have to go off the screen a bit to there, so multiplied by 2. The Y value is vertical scale factor of 2. Nice. Let's set that back to 1. And now let's try what happens to B. B, so the value of B, if I say B equals 5, then effectively I've got down here 4 to the power of 5 to the power of x. So 4 to the power of 5 is a different number for the base of this exponential function. The value of B effectively changes the base of the function, which is why the graph is changing there. I could get a similar effect if I set B back equal to 1. There it is. I could get a similar effect if I just changed the base. So changing the base changes the shape of the function, as does changing the value of B. So B is sometimes referred to as a change of base. Sometimes we don't even worry about B, we just use a different base. And what about C? Now that seems to be going a bit funny. Let's set C equal to 5, and let's set K equal to a nice number like 5. Now where did my other point go? Oh, it's probably off the top of the screen somewhere. How can I bring that back to somewhere a bit more easily? There it is, I found it. So let's have K equal to 2. Now, what have we got going on here? Well, if I set point A and B, I can see that when C equals 5, C is added here, plus 5, it's effectively shifted left by 5 steps. So from point 1 here on the x-axis to point -4. If C equaled 2, I'll just make that go back up to where it's in line, then we've effectively shifted this point 2 steps to the left. We could see the point there to point there. So that one and that one. 2 steps to the left. Well, I didn't quite, there it is, I locked it in. 2 steps to the left. So that's what C does. Finally, D. D, it's pretty obvious. D shifts the graph vertically by a fixed amount. Now, importantly with D, we're also shifting the location of the asymptote. You realise for the original graph here, the x-axis is a horizontal asymptote. So with D equaled 4 in this case, then this is the horizontal asymptote across here now, running through the point y equals 4. So that's pretty much it. And I encourage you to build one of these for yourself, have a play around with it, even use it to do your homework, or better still, do your homework and then use this to check your homework. Okay, thanks for watching.